fasten your seatbelts. It's time to take off in a world. What if? What would it be like to end up inside a giant, empty bubble? Even if you weren't alone there was no escaping the feeling of a heavy emptiness. Perhaps this was exactly what Kazimir Miljevic expressed in his painting, The Black Square. Absolute emptiness shocked the artist himself. But what if this paradoxical image was depicted in a real scene somewhere in space in 1915? Miljevic didn't yet know that within 63 years, astronomers would discover some of the strangest places in the universe, the strangest spaces between galaxy clusters, known as the void. The discovery in 1981 terrified people. American astronomer Robert Kushner and his team found an epic void in the universe, a giant circular region of space 330 million light-years in diameter, with no galaxies. This void, called the Botez Void, is sometimes called the Great Void. According to astronomer Greg Aldring, if the Milky Way were located at the center of the Botez Void, we would not have known about the existence of other galaxies before the 1960s. However, as it turns out, we discovered other galaxies in 1920. The Botez Void is the emptiest region of space in the known universe. In this entire void, only 60 galaxies have been discovered. For comparison, over a period of 3 light-years, our Milky Way galaxy is neighbored by 24 other galaxies. Considering that the average distance between galaxies in the universe is several light-years, then, in a vast region of space like the Botez Void, there should be more than 10,000 galaxies. The existence of such a void has fueled the imagination and thoughts of many, and of course, those wishing to visit this region should consider wisely and moderately. Fascinated by such isolation, and given the enormous distances separating the galaxies there, the view of this void from distant space would appear darker than black. This image is a perfect example of the most perfect void in space. Elementary particles such as photons and neutrons roam through it, particles whose properties do not change over hundreds of millions of years because they encounter no scientific obstacles in their path. Due to its extremely low density, the Botez vacuum can be considered an ideal time capsule that can provide us with a lot of information. But if you think what you just learned is about the most terrifying places in the observable universe, you are wrong. In 2004, astrophysicists focused their lenses on the cold emanating from the planet Eridanus, where they found an icy hell hidden somewhere there. Measurements of remnant radiation, or cosmic microwave background radiation, showed that this exceptional place has a much lower temperature than usual. The cold indicates the presence of a large vacuum, as radiation loses its energy when it passes through an empty region in its path, leading to the appearance of what is called a cold CNP point. A map of the universe's microwave radiation. Astronomers from Durham University in the United Kingdom have proposed that the supervacuum is a cluster of several smaller voids, each surrounded by galaxies. This means that the cluster should resemble a foam made up of a large number of bubbles, each representing a vacuum inside. The scientists argue that the total density of matter in the supervacuums, when compared to the surrounding galaxies, was the same as the density of matter elsewhere in the universe, outside of the cold spots. The map of the supervacuums of the universe, WMEP cold spot, shows the Eridanus supervacuum. It opens up many hypotheses, perhaps the most interesting of which suggests that the supervacuums are the result of our universe colliding with another cosmic bubble soup, says team member Tim Shanks. He believes that the cold spots may be the first evidence in the history of the human race of the existence of a multiverse, in which many parallel universes exist alongside our own. Meanwhile, the Great Void casts doubt once again on traditional cosmological thinking and puts the Big Bang theory into question. The entire universe is directly within range of the target, which relies on the homogeneous distribution of matter in the universe after the Big Bang. Therefore, galaxies should be close together and should not be separated by a large void. According to one theory about the formation of cosmic voids, galaxies tend to gravitate toward each other, leaving behind empty space. However, to form such large voids, the universe must have existed long before one scientific model suggests. Greg Aldring, who discovered the Botez void, believes that the large voids, whose existence cannot be explained, were formed by the merger of smaller voids. Furthermore, the Stone Digital Sky Survey allows you to see what is happening in the universe now. The voids appear to be expanding in all directions, causing galaxies to compress outward. It's pretty terrifying, isn't it? But there's more shocking information, and it's relevant to us directly. In 2013, a group of astronomers came to the conclusion that the Milky Way, along with the nearest galaxies, is actually located in the middle of a vast void 2 billion light-years across. Scientists have compared the amount of radiation reaching Earth from the nearest galaxies with that reaching it from farther corners of the universe. The picture appears as if humanity lives in the remote suburbs of our present, where the light of a large city illuminates the night sky of these suburbs more than the light coming from the windows of our homes and nearby houses. In other words, we would say to the inhabitants of Earth, "Welcome, inhabitants of the cosmic suburbs," say the study's authors, Ryan Keenan, Amy Barger, and Lennox Cowie, whose initials stand for the largest relative vacuum. The KP vacuum is a hotly debated topic in the astronomical community, and its existence would solve some fundamental problems. If the KP vacuum really exists, then it would explain the low density of galaxies in space. The ocean difference between the values of the Hubble constant, which represents the speed of cosmic inflation. This is one of the most difficult problems in modern astrophysics. Different methods of calculation have given different values for the Hubble constant. In the nearby part of the observable universe, the expansion rate of the universe is higher than in the farthest reaches of the universe. However, from a theoretical perspective, the Hubble constant, like any other constant, should not change with changes in measurement methods. Even if the Milky Way were in the heart of a vast vacuum, the matter obstructing the path of the cosmic microwave background radiation would be much less than its average density in the ordinary universe. By correcting this, it is possible to reconcile experimental data with precise measurements of the cosmic expansion rate. Life on the edge of a cosmic vacuum seems dangerous. Perhaps because of this cosmic vacuum, we struggle so fiercely with loneliness or seek to exist in the vicinity of other people. The universe is like a fine-tuned technology, like the burning of a luxurious Swiss watch, where everything is interconnected. If one part breaks, the entire structure collapses. But the difference is that watchmakers know everything about watches, while astronomers know almost nothing about the universe. Apparently, astronomers have already studied a lot, so the illusion fades as soon as new gas appears. In deep space, 250 million light-years from Earth, there is a gravitational anomaly of enormous proportions that people cannot even imagine from a distance. Therefore, it is likely that the enormous mass of many galaxies would be equivalent to the weight of about 105 Milky Way masses. If the anomaly is epically called the Great Attractor, the superattractor's effect on the surrounding galaxies could be likened to the Pied Piper of Hamelin. The Pied Piper of Hamelin enchanted the children of his town of Hamelin in Germany by playing a tune on his flute and leading them out of the town into a cave that closed behind them, never to be seen again. However, here the Great Attractor resembles the legendary Pied Piper of Hamelin, which pulls the blanket of the universe, drawing the Milky Way and other galaxies into its terrifying whirlpool. The objects are moving toward a great collapse at a speed of 600 meters per second. But what kind of irreversible structure do galaxies cause themselves? It is possible to assume that scientists have studied the visible parts of the sky relatively well, but this does not allow for a comprehensive investigation of the attractor due to an insurmountable obstacle, our Milky Way galaxy. The superfield is located in the zone of avoidance, or nebulae, a region hidden from Earth's sediments by the disk of our galaxy. The dust clouds do not allow us to know what lies beyond it, and therefore standard methods do not work here. However, using X-rays and infrared light can barely distinguish the silhouette of this gravitational monster, which magnetically attracts everything within a radius of 250 to 300 million light-years or more, according to recent estimates. The Great Attractor contains about 650 galaxies. It turns out that, in addition to its internal gravitational effects, this gravitational monster also affects us. Furthermore, scientists have also estimated that this factor represents 44% of the total strength of all gravitational forces. The final verdict is that all known galaxies have been moving toward the Great Attractor for billions of years. Where is the Great Attractor located? Since spacecraft navigation has not yet been invented, the exact coordinates of the object are unknown, but the approximate location is clear. This constellation is located in the southern hemisphere. In principle, superclusters would not surprise us. We ourselves live in the universe. One of them is called the constellation Virgo, which in turn belongs to the Laniakea cluster, a supercluster of galaxies that is home to the Milky Way galaxy. Do you think the math is done? Well, no, it's not done yet. All known objects are attracted to the normal cluster of galaxies and, in turn, to the Great Attractor. What a perfectly harmonious and thoughtful series. A fascinating contradiction was recently discovered when scientists attempted to create a computer model of the universe. The emerging, taking into account all known forces and influences, and as a result, no attractor appears in the diagram, which should not appear simply. However, denying its existence means not believing your eyes. This mystery will keep astrophysicists in a constant state of activity until it becomes a reality. What is the function of the Great Attractor? Many scientists believe that this strange place is a unique coordination center where matter gradually flows down from all corners of the universe. Matter accumulated for a long time, coalescing into large clumps like dust behind a wardrobe. Then one day, 0 hour struck, and matter rushed toward a single center. This, according to some scientists, is the mechanics of the process that was set in motion 1,314 billion years ago during the Big Bang. To reframe the idea beyond the point we came for, we will repeat the process again, as there are other, more exaggerated theories. For example, the Great Attractor is sometimes linked in theory. Multiverses are not in contact with each other and are radically different. But if you believe this hypothesis, then as soon as the inevitable happens, the protective outer shell of our universe will be torn apart. Now, through the Great Attractor, galaxies will gradually and inevitably be pulled into another strange universe. But let's move from the unexpected assumptions to reality. Everything is heading toward the attractor, but where is it heading? Astronomers at the University of Hawaii have determined the trajectory of the super collision, called the Shipley object, 65 million kilometers from our galaxy. The Titanic is amazing. It is 4 times heavier than the Great Attractor and ranks first in size among known formations. For the current universe, the super collision of the Shipley cluster is the most powerful gravitational center, literally transporting all objects in the visible universe to it. A legitimate question is what will happen when all the matter in space gathers at a point in one of the gravitational centers. Well, a new Big Bang will follow, and everything will start over again. Or perhaps portals to another dimension will open, or something even more impressive will happen. While scientists speculate, ordinary people also have time to think about this. Should we fear the Great Attractor? For us, our children, our grandchildren, and our great-grandchildren, we certainly won't. And then who knows what will happen? Some scientists discuss a theory that the Milky Way will never reach the Great Attractor because dark energy will inevitably tear apart the Norma cluster, which lies at the heart of the Laniakea supercluster, and the other clusters will remain unchanged. However, this theory won't apply to those galaxies that have already fallen or will soon find themselves in the jaws of the Great Attractor will begin to dry them up and deprive them of their hydrogen reserves. The end for such galaxies is certain death in total darkness, with no hope of reincarnation. One day, in the end, we hope that thinking about the attractor has brightened your day. Watch our channel and enjoy. We hope that, in the end, you will increase your knowledge and understanding of the secrets of this great and valuable universe.